All right. Hi, everyone. Welcome to the November 2024 WCMC meeting. My name is Emily Adrid, and I am the Water Planning and Climate Impact Specialist at CWCB. Today, we are going to have presentations from the Colorado Climate Center and NRCS. Russ, if you want to take it away, go for it.
Okie dokie. You see that okay? And
Yes.
okay, good. Well, here we go then. Morning, everybody. Yeah, we'll dive into the climate update. So I'm going to give a bit of a recap of the water year 2024, because I think at the timing of the last meeting, we didn't have all the data in from through the end of September. And so when Peter presented the last time, it was maybe an abbreviated water year recap. So we'll just summarize a few of those numbers and then look at, well, what happened in October, since there was no meeting then, and then dive into what we've seen in November, including the big snowstorm that happened a week and a half ago or so, especially in southeast Colorado and the southern mountains. Okay, so here's kind of the quick summary of water year 2024. So October 2023 through September 24. This is for temperature. So you can see most of the state had a top 10 warm water year, and overall in the statewide average, it was tied for the sixth warmest, tied with 2022. I'll show the other rankings in a moment. But if you look then through the rankings of the different months, almost all of them were warm. January, almost a year ago, was near average. May and July were also in that near average range, but June was really warm. September was really warm. August was also quite warm. So yeah, a very warm water year overall. If we look at precipitation for the 2024 water year, in the statewide average actually is very close to quote unquote normal, or the long-term average. But the interesting stuff is in the details as usual. The San Luis Valley was quite wet for water year 2024. Parts of northern and southeastern Colorado were quite dry, but on the whole, it was a near average water year. If we look through the months, then some of the more interesting things pop out, where there was some very dry months and some wet months, and those averaged out to the near average. So February, March were quite wet. April, May near average. June wet, but that was mostly in the west. July was dry. August was wet, again, mostly in the west. And then September was near average. So it ended up being right in the middle of the pack historically, as far as water year precipitation statewide. And here's the summary quadrant chart for water year 2024. We're used to looking at these. So again, a reminder, so it's precipitation along the horizontal axis, temperature along the vertical axis. So the upper left quadrant is the drought quadrant, warm and dry, warm and wet in the upper right, cool and dry lower left, cool and wet lower right. The long-term average temperature comes across here, the more recent 30-year average here, because it's been warmer. So here's where 2024 water year fits in. Again, sixth warmest, or tied for sixth warmest. And then near average in terms of precipitation. So just a little bit drier than average, but really kind of right along the average line there. You can see some of those other years that were both warmer and drier. So 2000, 2012, 2018, and 1934 up in the upper left corner there. Here's the time series going back to the late 1800s for water years averaged across Colorado. So 7 of the 8 warmest have been since 2000. The only one earlier that was really warm was 1934 in the midst of the Dust Bowl time frame. So you can see where this most recent water year ended up tied with 2022 and another quite warm one. And here's the same thing for precipitation. statewide average. And, this water year, just a little bit drier than average. But then, yeah, you can, see where the dry and the wet years fit in along there. Okay, so then that was the quick recap of the water year that ended a couple of months ago. We'll see what's happened since then. So we've had one full month in water year 2025, which was October, which was again extremely warm. A big swath of the state had its warmest October on record in the statewide average. It was the second warmest, behind only October of 1963. There was not anywhere in the state that was cooler than average in October. And a statewide anomaly, over 6 degrees Fahrenheit above average, which is quite a large anomaly for an entire month. Here was precipitation in October in terms of the historical ranking. The northern Colorado was very dry, very warm and very dry in October, and led to the expansion of drought and the worsening of drought in these areas, which I'll get to a little bit later. But that's clearly not a great combination of way above average temperature and way below average precipitation. So it led to the expansion of drought in that area. Southern Colorado was wetter during October. There were a couple of fairly big storms in October that brought heavy snow to the southern mountains and then rain to the southeast plains in that month. And then if we go back across so October was the second warmest October, but it ended the warmest September, October, the warmest October through October, August through October, the warmest July through October, June through October, May through October. Those are all the warmest on record for those particular periods there. And the calendar year of 2024 through the end of October was the sixth warmest on record. So lots of warmth being set there. A couple of interesting statistics and facts. These were in our October monthly summary, but in case you didn't check that out, kind of a fun precipitation fact here. So these are the graphs for May through October at Alamosa in blue, Denver in black, and Fort Collins in green. And it's not very common to have Alamosa on any time scale being several inches wetter than Denver and Fort Collins. So for May through October, on average, Alamosa gets about 5 inches. For this 6-month period, the Front Range areas get about 10 inches. But this year, Alamosa had 8.5. Fort Collins only had 4.5 over that time period. There's only 2 other times that Alamosa was wetter than both Denver and Fort Collins from May through October, and those were by like a 1/2 inch. So this is by far the biggest margin where we had the San Luis Valley way wetter than the Front Range. So that is not the sort of thing that happens very frequently. Okay, so November thus far, we're now more than halfway through the month somehow. This is month-to-date precipitation through Sunday morning. There was a little bit of precipitation yesterday in the mountains, but this captures the pattern pretty well. So big precipitation amounts in southeastern Colorado from that big storm a week and a half ago or so, and we'll dive into that in a second. Lower amounts up along the northern Front Range, although still got some from that recent storm. A bit drier on the western slope, but the mountains have been getting precipitation, as we'll hear about from Brian in terms of the early snowpack. And here's where that looks in terms of the percent of average for November through the 17th. All of eastern Colorado above average for the month to date. November is typically not a really wet month, so getting a storm that drops, 2, 3, 4, 5 inches of precipitation is pretty unusual. Western Colorado more in the average range, some spots that have had above average, some below, like down near the Four Corners, but otherwise, not as extreme closer to average in November for those areas. And then this is precipitation departure from normal through the 17th. Southeast Colorado, where all that snow fell, and the San Luis Valley are quite a bit cooler than average for November. The northern part of the state closer to just a degree or so below average, a little bit closer to average there. Having all that snow on the ground keeps the temperatures down. So there's some feedback process there that if you get 20 or 30 inches of snow, your temperatures are also going to be below average for a time until that snow melts. So yeah, we'll take a little bit of a closer look at the snowstorm from earlier in the month. If this is some stuff that I put on a blog post on our blog, so if you're not subscribed to that, you can subscribe there on the site and read more of this at your convenience. But this was a really significant snowstorm on the eastern plains, especially the southeastern plains. So this was the observed snowfall for that storm from the 5th through the 9th or so. Really, it ran like the 4th through the 10th, with a couple of periods of heavy snow during that time period, but some really big amounts. Reports the Sangre de Cristo Mountains with 50 to 60 inches, multiple reports of that. And then some really big amounts at lower elevations as well, as I'll show, and even into the Oklahoma Panhandle and northern New Mexico. So I looked at the Eastern Plains lower elevation snow events on the Eastern Plains. So this is 7-day snowfall totals at stations east of 104.5 longitude. So essentially it's east of the foothills and the mountain areas. So the champion snowstorm historically in the lower elevations in eastern Colorado happened in early November of 1946. This was a really epic snowstorm that it was 50 inches total snowfall at Eads, which is kind of hard to believe. 46 at Carvel, 30 or 43 at Trinidad. So that I think remains keeps its title as the biggest low elevation snowstorm in southeastern Colorado history. But this one from this month, it shows up on the list at numerous stations as well. So there's 46 inches at a Kokoraz station, northeast side of Trinidad, 41 at Deer Trail, 34 at Hugo and Simla. So those are really big snow amounts that don't come around very often at the lower elevations of the Eastern Plains. So I think this recent storm ranks right up there, not quite at the 1946 level, but pretty close to it. And it was really wet snow as well. So this is now liquid equivalent precipitation. So looking at that period from the 5th through the 11th of November, the amount of precipitation that fell just during that week in comparison to the entire November through February average. So anywhere in this lighter green shading here, already will have a wetter than average November through February just from this 1 week. Anywhere in this darker shade of green here has more than double their November through February average already. And then there's a couple little dots here in this data set, at least, where it's 3 times the average in like one little spot in Lincoln County. And a couple little dots in further southeast. So this is a really huge storm in terms of precipitation. And again, this is typically the dry season on the far eastern plains. We don't tend to see 3 or 4 or 5 inch storms in terms of precipitation at this time of year. So it's done a lot also for the drought conditions there that we'll get to. And some locations have already exceeded their average snowfall for the season. The few spots in purple here are where this one storm exceeded the seasonal average, and the ones in green are where it's within just a few inches of that. So it was a big one for southeastern Colorado, and it's been warmer over the last week. Some spots it's already melting out, but there's still plenty of snow in quite a few places down there. Okay, well, so we'll see how that plays out on the drought monitor. So this is the national drought monitor map from last week. Does incorporate the effects of that snowstorm here in Colorado, but you can see a broad swath of the country still in drought. So the previous week's map set the record for the largest coverage of D0, or basically the largest coverage of some color on the map, at about 87%. That went down a bit in the current map, so it's 83% of the CONUS now has a category on the map. So it's among the top few weeks since the drought monitor established. You may have been hearing about drought in the Northeast and wildfires going on there, and a lot of the Midwest and the Great Plains and the southern U.S. Still in drought conditions as well. Here's the Colorado zoom in. So big improvements in southern and southeastern Colorado, but still some pretty substantial deficits over northern Colorado. The Front Range, we still see D3 over parts of Larimer and Weld County, and an area of D2 surrounding that. We didn't get nearly as much precipitation in that storm. It was certainly welcome. I had 0.91, I think, at my house, which was the wettest day in several months, but did not do all that much to remove those long-term deficits, whereas the 3 to 5 inch amounts in the south very much did. Here's the 1 week. This was the improvement on last week's map. So a 2-category improvement in southeast Colorado, where those biggest amounts took place. It's actually pretty unusual to get a 2-category improvement on the drought monitor. The authors don't like to do that unless it's like a hurricane or something, but I guess this was the equivalent of having a hurricane rainfall from that storm in southeast Colorado, and then broad improvements over much of the rest of the state following from that storm as well. And here's the 6-week change. So this goes back to the start of the water year, to October 1st. So now you can see, again, much of southeastern Colorado has improved over that time frame since October 1st, but with how warm and dry October was in northern Colorado especially, that's the area that has seen the drought situation get worse since over the last 6 weeks or so. Take a look at soil moisture. This is shallower soil moisture on the left, deeper soil moisture on the right. Where you see the blues is where it's above average. This is in terms of percentiles. And then where you see the yellows and reds, it's below average soil moisture. So you can see the influence of that big storm across eastern Colorado, where quite a few areas were showing below average soil moisture from the hot, dry summer in eastern Colorado. Now there's a lot of dark blue there, where for this time of year, the soils are very wet, given the amount of precipitation that fell. The deeper soil moisture similarly covers a lot of eastern Colorado, the San Luis Valley, but then you still see the soil moisture deficits in much of northern Colorado, where the recent precipitation hasn't been as much, and October was really warm and dry that dried out the soils. And this is another new similar map. So we actually have a project that we're working with a group at NASA so we're running this land surface model now on our computer at CSU and trying to evaluate some of the outputs in addition to soil moisture. So this is one that we've started looking at, and we're not still, we haven't kind of totally gotten calibrated to it, and we'd be interested in any feedback anyone might have. This is one of the products that we can output, which is the terrestrial water storage. So this is the combination of groundwater and soil moisture and water in the snowpack. So I think this will be one that we take see how it behaves over the snow season, because we haven't really looked at it very much. But it also, at least in principle, incorporates the groundwater conditions, which in southeast Colorado, of course, over the last decade or two have gotten much worse. So you can see that soil moisture here looks, ample. It probably, in the total amount of water, then that helps a lot, but there's still groundwater deficits there. So if you have any thoughts on products like this, please let me know, because we want to tell NASA, whether this is a useful product, and over the coming months, we'll show you some more of the things that we can look at in here and how they compare to some of the other tools that we have. Okay, well, let's take a look at the outlook going ahead. ski areas are open now, some of them at least. So, and those of you who are skiers can start to look at that. Here's the 7-day precipitation forecast from NOAA's Weather Prediction Center out through next Tuesday morning. So some rounds of snow in the mountains over the next week. That's not a ton of precipitation for this time of year in the mountains, but the pattern looks like it's going to at least favor getting snow on a fairly routine basis over the next week or two. Not much precipitation in the forecast for the plains, if any. And here's how that compares to average. That snowstorm earlier in the month was really an anomaly. We typically don't see much precipitation at all in mid to late November on the eastern plains, so it's not that unusual to see little to no precip there. A little bit above average if those amounts pan out in the mountains over that time period. So kind of a typical week maybe upcoming in terms of precip. And here's how that breaks down. There's the same two maps on the top, and then the evolution during the different days. So really that mountain snow, aside from what's falling right now and is winding down in the mountains, looks like Sunday, Monday into early, later next week is when the precipitation chances will come back up in the mountain areas and potentially on the plains as well after that time period. So just a couple of these plume diagrams. This is temperature at Denver from an ensemble of weather prediction models that goes out about 2 weeks. The climatology average is the gray lines here for the high and the low temperature. So cool today and tomorrow, then warming back up for the weekend. So it should be a really nice weekend. And then cooling down into next week. So not going to be doesn't look like it's going to be a real warm Thanksgiving next week. So cooler, generally cooler than average conditions through there, and associated with at least some precipitation chances through there. This is at Steamboat for precipitation, again, from a similar ensemble, this is a different weather model ensemble, but kind of gives you the sense that after the snow winds down today, dry for several days, and then the snow chances in the mountains pick back up Sunday, Monday through some portion of next week. And the models also show some chances of lower elevation snow sometime early to mid next week, but a little bit far out to know a lot of details there. And this is the 8 to 14 day outlook, which is pretty consistent. This is essentially for the Thanksgiving week, the 26th through December 2nd, tilted towards cooler than average conditions, especially in the northern part of the state, and wetter than average over that 8 to 14 day period. And then looking farther out to the full winter outlook and what might happen there. So the seasonal outlooks have been a little bit, I don't know, messy and confounding over recent months. If you remember back to the summer, there was a lot of thought that La Nina was going to come back with a vengeance and go really quickly from the La Nina that we had previously to a really strong or the El Nino we had previously to a really strong La Nina, but that didn't really pan out. Now it's looking like the La Nina does look like it's going to happen, but it looks like it'll probably be weaker and shorter duration. So here's some snippets from the CPC outlook that now it's only a 57% chance that it's going to emerge in October through December, a little higher. It'll be there in the winter, but a weak and short duration La Nina, less likely to result in conventional winter impacts, but maybe still some predictable signals there. So that aligns pretty well with what we see in the seasonal outlooks for winter in Colorado. So this is a pretty La Nina type outlook for temperature, with cool conditions across the northern tier of states, cooler than average, warmer than average across the southern tier of states. And then here in Colorado and other parts of the Great Plains and the Midwest, we sit right in the middle, and the influence of El Nino and La Nina on our winter conditions is just not all that strong. And then this is precipitation, similar story. So some tilt toward drier than average conditions in the south, over that December, January, February period, but not a lot of confidence and not a very strong signal for much of the state. So I think that is still, the seasonal outlooks are always a question mark, but I think maybe even more of a question mark this particular winter. And I'll highlight just one other thing. You might have seen this. This was kind of going around a lot last week from an analysis from the Washington Post. This was an outlook for winter snowfall. And it was sort of interesting that this came out right after southeastern Colorado had one of their biggest snowstorms on record, with this big swath of lower than average snowfall across most of the state. Now, keep in mind that this is for the December, January, February time period. And I think this aligns with a La Nina type signal where the southern mountains do tend to be drier and get lower snowpack, and the northern mountains do better. So that may still end up being the case over the core of winter. But keep in mind that in southeastern Colorado, many places, even if they get no snowfall from December through January, which would confirm that particular forecast, they will have a snowier than average snow season from that one storm that happened there. So some takeaways. Recapping water year 2024 again, it was very warm, tied for the 6th warmest statewide. Statewide average precipitation was close to average, but of course, as usual, there was some, some parts of the state were wet, some parts were dry, and that averaged out in the statewide average. October was really warm. It was really dry in northern Colorado, and the 6-month period from May to October was the warmest such period on record. November then changed in a big way with a huge snowstorm in southeastern Colorado. That's helping with drought situation there, but the severe drought remains in parts of northern Colorado. La Nina still expected for this winter, but not as strong as some earlier predictions were hinting at. La Nina does tend to favor more snow in the northern mountains, less in the southern mountains, but because it's a weak La Nina and that signal just isn't very strong to begin with, I wouldn't put a ton of confidence in that. And I think in general, the winter outlook for Colorado and surrounding areas is lower confidence than usual. Not that we ever have real high confidence in the seasonal forecasts. So that's what I've got. There's my info. Everybody's moving to Blue Sky now, right? We set up an account there. So if you're there, feel free to follow us and check out the blog and subscribe to the monthly updates if you don't get them. And that's what I've got. Thanks for your time, and happy to take questions if there are any. And I can't see the chat, Emily, so if there's anything in the chat, feel free to yell it out at me.
Yeah, thank you, Russ. We just have a comment from Swithin. He said he thinks the terrestrial water storage products will be helpful for predicting spring water yields.
Ah, that's great. Thanks, Swithin. Yeah, and maybe Swithin, we might get in touch with you about that as we get closer to that time frame, just to maybe you can have a look at it and see if the data actually makes sense, because we're still trying to figure that out ourselves.
Yep. No, I think it'll be, instead of us trying to do it in our minds, I think that'll have it graphically represented. So yeah, anytime I can help you guys out with whatever little left of my brain there is, go ahead and pick it.
Any questions for us?
Okay, now I can see the chat.
Okay, awesome.
Question from Adriana. Is it likely to be typical for large snowstorms than consistent historical average snowstorms? I mean, are you thinking like in the context of climate change, or just like how the climate goes, in that some years you get big storms and some years you get nothing, and it averages out to the average? So that, I mean, that's a piece of it. And if you are thinking of it from a climate change perspective, I think the answer is we don't totally know. So like because there's, with snowstorms, there's so many competing factors, right? So on the one hand, there's, in a warmer climate, we expect more moisture to be available And so the potential for a big wet storm like that probably goes up, but in a warmer climate, it's not as cold. And so some of that maybe ends up being rain rather than snow. And it's at the lower elevations, especially. I mean, general projections show, say, southeastern Colorado snowfall decreasing mainly because the snow season gets shorter and because it's warmer. So it's the idea being that the temperature effect probably wins out. But I'm still, when it comes to these big storms, that's where you start to wonder about that, because a case like this, it was just cold enough for snow at a lot of those locations, and that's actually that's like the best scenario to get the most snow, is if the temperature is right, just a little bit below freezing, such that there's a lot of water, but it's cold enough for it to be snow. So anyway, it's a very wishy-washy answer. I think the main answer is we don't know about that all that much. And then just from like precipitation in general, the general expectation is that like mountain precipitation in the winter probably will go up in a warmer climate, but then the snow season gets compressed, and so more rain on the shoulder, or more precipitation on the shoulders ends up being rain rather than snow, and so yeah, how that all plays out is still a little bit up in the air. It's a good question that we all would like the answer to, I think.
Awesome. Well, thanks for the question. And if there are any more questions, feel free to just put them in the chat.
Yep.
Thanks again, Russ.
Or drop me an email. I'm gonna have to drop off in 5 minutes or so. So
okay,
send me an email if other folks have questions. Sorry, Brian, I won't be able to stick around for your whole talk.
Oh, Brian, I don't know if we can hear you. I can see your mouth moving, but
Ryan, I think you're muted.
Yeah, you sounded great at the beginning, but I can't hear you now either.
No, can't hear you.
About that.
That works.
Okay.
Cool.
Can you still hear me?
Yes.
Okay, awesome. Sorry, headphone, new computer, but it sounds like we
no
got
worries.
something that works here.
Before you start, I just want to ask everybody I didn't ask this at the beginning, but if you could put your name and affiliation in the chat, please, that would be great. Okay, go ahead, Brian.
Yeah, thanks, Emily. Yeah, and Russ, as always, great presentation. There's some great information in there, and it's really cool to see the accumulation amounts in Southeast Colorado, and then some of the differences that exist in the accumulations in the mountains, just between the plains and the mountains. And I really appreciated Russ's soil moisture products there, especially in the northern half of the state. We really are seeing those dry conditions, and so I think that's something I'll get into here in a little bit with the presentation. So let me share my screen before I get talking too much. Let's see. I think it's this screen. Let me share and see if this is what comes up. You guys seeing the presentation?
No.
It wants to share one of my products as opposed to my screen. All right, let me try and see. Doesn't want to seem to share that screen there. It only wants to share applications. Well, let me try this one and see if I can. Sorry for the delay.
Oh, that's okay.
And I'm clicking share, but it's not.
Oh. Okay, I see your slides in PowerPoint.
Okay, you do see the slides. All right, great.
Yes.
Okay, let me switch the screen. Still not cooperating. All right, is it showing the main slide in
Yes.
presentation mode?
Yep.
Okay, excellent. All right, so what I'm planning on doing here today is giving an overview of the water year 24 year-to-date precipitation, because we have, or during the last presentation, we hadn't quite rounded out the water year at that point. So I was going to go and highlight how the water year occurred across many of the mountains in Colorado. I was not going to go over snowpack for 2024 because we went over that in July and June, but did want to go over 2024 year-to-date precipitation and then really kind of build it into what that means for this water year in 2025 as we dive into winter and what that could mean for runoff in 2025. So this graphic, this map here is showing statewide precipitation across Colorado. So for the statewide total number, we did have 101% of normal statewide precipitation for the entirety of Colorado. But looking at the map, you can see that, diving into some of those basins there was a little bit of variability across some of those basins. But in reality, the variability wasn't that great. So you can see the South Platte was 95% of median total precipitation, whereas on the upper end across the state, the Gunnison was 110% of normal. So this is actually quite a tight target here. There was not a lot of variability across the state. I know there's a number of years in the past where we've had greater variability. Typically it winds up being a bit drier in the south and wetter in the north. But for 2024, surprisingly, things were quite consistent. So that's good news there. Looking at it from a time series standpoint, and here we're going to look more particularly for the moment at the orange line, which is the trace of 2024. We can see again, looking at the very last day of the water year, that precipitation was very close to normal, which is indicated by the green line. And again, it was at 101% of normal. Now, for this particular graphic, and for the purposes of the 2024 water year, we're not going to look at this value. This 105 value is where statewide precipitation is at this point, but for 2024 we were very close to normal statewide. Looking at some of the individual basins around the state, so let's go to the extreme on the lower end. The South Platte was 95% of normal. In the beginning of the year, precipitation was relatively low until about winter time, January, February. We started to see a bump. We started to see near normal precipitation, and then got a boost through much of spring, late winter and spring, but then things dried out again through much of the summer in the South Platte Basin. And you're going to see a theme here in the northern half of the state. Moving into the southern half, in the Arkansas, one of the better basins in the state for 2024 precip, you can see that we ended the year in and above the 70th percentile. So looking pretty good there. Again, don't key off this 163% of normal, just for the purposes of looking at the 2024 water year. We ended at 109% of normal here. Now, we are very fortunate to have seen that the Arkansas River Basin did get a solid boost from those storms that Russ highlighted. And again, here we're talking mainly or entirely about the mountains and the precipitation received there. at the SNOTEL sites. But in terms of 2024, the water year was dry in the beginning, and then when winter came around, we got solid precipitation in the form of snowpack, and then through spring and summer we continued to get pretty good precipitation in the form of rain, and the Arkansas has been one of the best basins in the state for precipitation, with the exception of the Gunnison. Looking in the southwest corner of the state, the San Miguel, Dolores, Animas, San Juan basins, things were considerably drier there through pretty much the entirety of spring, including the winter. And then this second half of the year, or maybe not quite second half of the year, but you're thinking about it from spring, summer kind of standpoint, we did receive much better precipitation. So we went from that kind of about 20th percentile up to almost the 40th percentile, but had a little dry spell there right before the end of the year. And as indicated by the orange line compared to the green line. So in the end, when we look at the entire water year, I feel quite confident that we did pretty well in the San Miguel, Dolores, and the San Juan basins, thanks to the end of the year precipitation that we got down there. And then just a quick highlight on 2025 precipitation so far in this combined San Miguel, Dolores, and San Juan. We did see some good bumps or good improvements out of the first two storms, but the western portion of the state, particularly down in the very southwest, did not receive the storm totals that we saw in the Arkansas. And then looking at the Colorado headwaters, precipitation really tracked quite close to normal throughout the entire year here, and then ended up just slightly above normal into 2024. And then here in 2025 in the Colorado, just looking pretty close to normal, to the hair below at 88% of normal. But we are still very early in the year here for 2025. So as I've been highlighting in those previous graphics, I wanted to draw out particularly what precipitation has been in the last 3 months of the 2024 water year for the individual basins. You can see, as I've been highlighting, that the northern basins have been running low in precip, both compared to normal or median and compared to the southern half of the state. So again, this is just for the last 3 months of 2024. So the Arkansas is not super high because that November storm and some of those storms in October are not reflected here. But the improvements that we saw in basically the San Juans and even in the Grand Mesa area really did wind up helping out. And we did have some decent precipitation in the Sangre de Cristos, and some of those central mountains did help out. So it's made a good difference, but still dry in the northern half of the state, something to pay attention to here going forward. So I really already hit on this. I won't talk on this too long, but now focusing on 2025 and the precipitation that we've seen statewide so far, we are very close to normal at 105. Still very early in the year. We're only a month and a half in. A lot to change. A lot could change through the remainder of the year. So sadly, at least for the northern half of the state, the precipitation that we've received in the new water year 2025 has again been subpar. Whereas in the southern half of the state, we've seen great precipitation, not just in the Arkansas River Basin, but also further west in the upper Rio Grande and the combined San Miguel, Dolores, and San Juan. Not so much in the Gunnison, but still closer to normal, and seeing kind of that transition period into the northern portion of the state. All right, so what does this mean, all the precipitation that we have or kind of have not been receiving? And we're basically at a critical point here in the year where we're going into winter. When the mountains go into winter, everything kind of freezes and shuts down in the state that it was in the fall here, which is about this time frame right now and a little bit earlier. And then when spring comes around, things thaw out. In most cases, the antecedent soil moisture or antecedent moisture conditions that we saw in the fall then arise in the spring. We see those same conditions, provided there weren't any large changes or kind of anomalies out there. So what I would like to do is continue to bring the idea forward of where precipitation was leading into the winter, and show where soil moisture is to get that greater picture of what antecedent moisture is doing now and what it should look like in the spring. So we have a limited number of soil moisture sensors across the state. Moreover, we have a limited number of data at those sensors. So we usually like to have at least a few years worth of data before we get them up here on the map to have the data to really trust what they're putting out. So for example, in the South Platte Basin, we only have 2 sites that have this 8-inch, or excuse me, 3 sites that have this 8-inch soil moisture providing data that we can use. So I'm not really going to hang my hat on a lot of this data, but just use it as an indicator of what's kind of going on. And the reason I mentioned Russ's product earlier with soil moisture, particularly as we were looking at the mountains, if you can remember those mountainous areas, they were pretty dry. And this is kind of backing up Russ's product there. We are kind of seeing that. So while I don't think that soil moisture conditions are maybe as low as these numbers would indicate, I do think that we have soil moistures that are running low, and just antecedent conditions in general that are running low. And there's 1 or 2 other graphics I'm going to show here that will continue to show that. But in the southern half of the state, things are looking pretty good. It looks like soil moisture is at least near normal or slightly above normal. Not really hanging my hat again on some of these numbers, but feel pretty confident that we're getting a general idea of what's going on there. And here we go again, looking at the 20-inch sensors, really kind of seeing that same story. Drier in the north, wetter in the south for those soil moisture conditions. Not exactly above normal in all locations in the south, but still looking considerably better than in the northern part of the state. So feeling better about that. And hoping that some of these values in the southern end of the state will mean that snowpack runoff efficiency will be better, hopefully. Okay, so in the next 4 or 5 graphics, I'm going to be showing a section of this particular graph here. If you've been to a number of my presentations in the past, you know that I like to show these snow to flow plots. Basically what it is the snowpack here, indicated by the kind of rainbow colors that exist, medium being the green line, black being the current snowpack values, and then the gray scale and the items over here are the stream flow volumes for this particular stream gauge, right? So you can see that stream flows are typically pretty low throughout the winter. And then as the snow melt starts to melt off, we start to see the stream response. And that's this hydrograph here. What I'm going to do for these next few graphics is I'm going to zoom into this area here, just to kind of show where stream flows are at for these areas. Looking at the Arkansas River at Pueblo, one thing to keep in mind with this one is that this is a heavily managed or human controlled river, right? So we can see that the current stream flows indicated by the black dotted line are for the most part below normal, with the exception of some of the stream flow runoff in response to those storms that we got. But we're also seeing here, you can see that the average line indicated by the green dotted line is diving off pretty quickly. And we're also seeing that the current stream flow observations in that area are also going down as reservoirs are being closed off, is my guess. So that's pretty typical for this area because it's indicated in the normal line. Moving into the Rio Grande del Norte, we're looking at some pretty good stream flows here. While there is some human control on this, I still am feeling pretty confident that we are seeing stream flows above normal values at this time of year. The general trend is for downward this time of year because gauges are starting to, things are just getting cold, right? And flows are going down because of it. But I am still feeling good that stream flows are above normal, particularly in the Rio Grande. Going to the other extreme in the state, the North Platte, you can see that stream flows, as of the last data that we received in the earlier part of November, stream flows are below normal. Again, normal, the green dotted line, this year, the dotted black line. And then finally, looking at the Colorado River at Dotsero, excuse me, just a little bit below normal here, but comparing quite closely to 2024, which is that orange line. I'm sorry I didn't put those into those other graphics, but it is trending relatively close to normal, a little bit below, but in line with what was happening last year. Again, there could be some management decisions there. So are showing some drier conditions in those northern basins. and slightly wetter in the southern basins, which is a good place to be in the southern half of the state. Another way of looking at the stream flow volumes, here on the right, we're looking at October total stream flow values, and on the left, we're looking at September total stream flow for those gauges that have the data. And those gauges that have the data are indicated with colored dots, and then the normalized value or the summed values exist in the basin-wide numbers here. So I draw attention to the sites that have data in them because I'm a little bit concerned, or I shouldn't say I'm concerned. I am not hanging my hat on the values in the South Platte. You can see that as of the 12 data collection sites that we have for stream flow values, we only have 3 in the South Platte. So I wouldn't hang my hat on those values, and I'm not going to put a lot of value there. But I do feel more confident about, the Colorado River headwaters, see a fair number of values in there, and it is indicative of what we're seeing in a lot of the other conditions from precipitation and soil moisture. Same goes with the Arkansas. I do think that stream flow values have come down because of management, but being as the October value here is removed for Pueblo, I feel pretty confident based on some of the conditions that we're seeing that this is probably true, at least on this right graphic for October. And since November is not complete yet, we don't quite have these values, but they will be available here at the end of November. Okay, so those previous graphics really kind of paint the picture for drier in the north, wetter in the south, in terms of antecedent conditions when we see streamflow runoff in the spring. That's more than likely what we'll see, unless we see some really crazy conditions, or I should say very anomalous conditions come winter that might be able to change those conditions. But usually those antecedent conditions really kind of solidify in the ice, figuratively and literally, in the fall, and then reappear in the spring. So looking at reservoirs, statewide, we're 98% of normal, quite close, but you can see it's kind of variable across the state. The South Platte is showing really high reservoir storage, where other portions of the state are not quite so high. And excuse me, I should pinpoint that this is the lower South Platte. We're looking at 233% of normal reservoir storage. In the upper South Platte, we're looking at 121, still above normal. So you can see there is some variability across the state, and I would highly encourage everybody to drill into the data of interest to you. There's quite a fair amount of variability here. If there's a reservoir that you're interested in, you can go to our products online, such as the interactive map here, where this map was derived from, and you can click on these values and see what the history has been on that data. Another way of looking at reservoir storage here, for the most part, conditions are relatively close to where they were last year. Last year is indicated by the green or bottom line here for each of the major basins. And then this year is indicated by the aqua line there on top. The bigger discrepancy is there in that eastern South Platte. You can see that we're running a good bit higher for reservoir storage there, but everything else in the state is relatively close to where it was last year. Okay, and finally, looking at snowpack, we are still very early in the year, but there's some good things to build on here. So hopefully, the good numbers that we're seeing right now are going to carry throughout the year. Some of the outlooks that Russ put up on the screen weren't exactly promising. Kind of the Washington Post image is kind of sticking in my mind, but there are equal chances, as Russ was pointing out, for portions of Colorado, and that's a bit more optimistic than what we were seeing in some of that Washington Post article. So as of right now, snowpack is 115% of normal statewide. In another graphic, you're going to see 116, little bit of difference in the way or timing of the those calculations there. But we're still very early in the year. You can see that we have another 85% of the snowpack accumulation season to go. So there's a lot left to change. And there is some variability in those current conditions. So while the statewide is 115% of normal, some of the basins, which I'll get into here in a little bit, are a little bit more variable than that. We have seen 3 major storms across the state. At first, on October 18th, snowpack was about 200% of normal. And then we saw that about a 3-day storm variable across portions of the state, which doubled the snowpack. Don't be surprised by these numbers. This is all very normal for this time of year. When we're looking at very low snow values, these numbers can be conflated. And then just 7 days later, the snowpack went from 400% of normal to 80% of normal. Again, very normal for this time of year to see that happen. Nothing out of the norm. That storm then doubled the snowpack. And then we dried out for a few more days and then saw another improvement in snow across much of the state. So as I mentioned earlier, at this point in the year, we're only 15% of the way into the snowpack accumulation season. We still have a lot to go. So looking at what the statewide snowpack is in the individual basins here, we can see that those storms, much the same as we've seen in precipitation, have really been focused in the southern end of the state. Not to say that we haven't received near normal precipitation in the upper Colorado and in the headwaters of the South Platte. We are still seeing significantly more snow compared to normal in those southern basins, whereas the northern basins are, at least the South Platte and the Colorado headwaters are very close to normal, but the North Platte and the combined Yampa White are hanging a bit below normal there. So this graphic was particularly showing a 116% of normal snowpack as of yesterday morning when these data were compiled. And then drilling down into some of those sub-basins across the state, again, larger take-home point is that better snowpack in the south and looking for some more snow to get things back to normal in the northern portion of the state. Okay, so breaking down into some of the individual basins and how snowpack has behaved so far. Upper Rio Grande's looking pretty good. We're there in about the 80th percentile for snowpack in the Upper Rio Grande. And then 2024 again is indicated by the orange line there. Going further north into the Laramie and North Platte, we can see that we're below normal, 77%, but above where we were last year. So taking that, last year was pretty dry across almost the entire state until about midwinter here. I think that was the trend for much of the state, but still below normal at this point in the year. Looking at the South Platte, this graphic is showing 100% of normal snowpack. We did get a bit of a boost out of this most recent storm. That was we've only had really one solid storm here in the mountains of the South Platte Basin, and that one, sorry, trying to bring up my pointer, and that one was about a few weeks ago. So, or actually, yeah, a week and a half ago, we received some pretty good precipitation there. Okay, and now highlighting the Arkansas River Basin, we did see pretty good accumulation in the mountains, just like Russ was saying. Now, the plains, that seemed to be a little bit more extreme and a great near, I can't remember if Russ said it was near record or not, but I don't quite think that this snowstorm here was near record. I didn't get a chance to look at that. Definitely a sizable improvement. We did get into record total snowpack territory, but I can't speak specifically for that storm if that was one of the bigger ones for that time of year. I do know that for later in the year, this is, not an out of the question storm that we saw, or those totals were not out of the question. But you can see that we have dried out since then. We still are at about the 90th percentile for total snowpack right now in the Arkansas River Basin, and there's still a lot of winter yet to happen. So in summary, water year-to-date precipitation was 101% of normal last water year. This current year and in 2025, and basically over the last 4 months, things have been drier in the north, but better and more snow, more precipitation in the south. which honestly leads to better antecedent conditions as we go into a winter here, as things really start to freeze over. And then hopefully those better conditions in the south will persist through the winter and lead to better runoff efficiency. Hopefully we'll have good snowpack to run off as well. So right now, snowpack is at 116% of median statewide, but considerably better in the southern half of the state, and then near normal in the South Platte and Colorado River basins, and then below normal in the Yampa White and North Platte basins. And then reservoirs are at 98% of normal. That's all that I got.
Awesome. Thank you, Brian. There is a question in the chat, and Russ was able to give some of an answer, but I was curious to know if you had an answer as well. Why are there so few soil moisture sensors if more would be better to interpolate each basin?
It's a sensor that historically we have not put a lot of we have not had a lot of time to install and maintain. However, it is one of our objectives is to hopefully increase the number of soil moisture sensors that we have across our entire state and our larger office. It will take a lot of time, as permitting and installation and maintenance takes a fair amount of time, but it is something we are working on. So hopefully we'll have a more robust network in the near future, which is probably in the next 5 to 10 years, I would hope.
Awesome. Yeah, and
Great
Russ
question.
provided a link that kind of explains that there's going to be a new project underway to add more soil moisture sensors in the state. So stay tuned for that. Any other questions for Brian? All right, well, hearing none, thank you so much, Brian.
Thank you.
Yeah. All right, so we are towards the end of our meeting. I want to open up the opportunity for you all to provide any updates. If we have any water providers or water managers or municipalities, or water conservancy districts. If there are any updates on conditions where you are, we'd love to hear them. I can also call on people as well.
I'll go ahead. Can you hear me?
Yeah, you're a bit quiet, but I can hear you.
I'll try and speak loud. Nick Harris, Colorado Springs Utilities. I think, kind of our situation echoes really what was said by both presenters. Also, thank you to both of those gentlemen for doing that and you for putting this on. I think our snowpack for some of the basins that we monitor and some of our internal monitoring locations are pretty high, ranging from 150% to 300% of normal. I do agree with, kind of what's been said that we are very early in the season. So a few inches either direction makes a very large change. But overall, Colorado Springs Utilities is looking pretty good. And we hope that we get some more snow like that as the winter continues.
Great. Yeah. Thanks, Nick.
Yeah.
Anyone else? I see Ryan from Pueblo Water and Beverly from Upper Gunnison. All right, well, maybe they are multitasking, but I wanted to put a link in the chat for our 2025 WCMC meeting schedule. We will skip December and we will meet back again in 2025. 2025 on January 14th. So this is the PDF that outlines all of the days that we'll be meeting next year. So you can put it on your calendar. I'll also be sending a follow-up email with this link. So with that, I think we can conclude this meeting. Thank you all so much for being here, and I hope you all have a great holiday season.
Thank you, Emily. You too.
Thanks.
Yeah, thank you, Emily. Thank you, everyone.